Hello guys, and welcome to lesson 2F. I can write a 2-column geometric proof. Well guys, last class we talked about algebraic proofs, and those were easy for us because we've been solving algebraic equations for ages and ages, and all we had to do was give the reasons why we could do each step. Well, today we're going to dive much more deeply into the theoretical study of geometry by looking at how to prove theorems. And a theorem is a statement, usually a conditional statement, that we prove, that has to be proven to be true. By contrast, we've actually already run across a couple of postulates or axiom statements, which are things that we accept to be true without proof. So for example, we saw the segment addition postulate in Unit 1. That was that two parts of a segment add together to be the whole segment postulate. However, we never make an assumption that a theorem is true. We can only use postulates and theorems that have already been proven in order to prove a new theorem. Our conditional statements actually give us a great framework within which to look at theorems. All theorems should be able to be written in conditional form. The hypothesis of my conditional represents my givens in the proof, whereas the conclusion is going to be what we need to prove in order to prove the theorem. So for example, if we are proving the vertical angles theorem, the vertical angles theorem states that if two angles are vertical angles, then they are congruent to each other. Well, my hypothesis is two angles are vertical angles, and my conclusion is they are congruent to each other. Well, now guys, I actually don't want us to prove the vertical angles theorem first. So even though it says we're going to do the vertical angles first, we're going to skip ahead and go into the linear pair theorem and talk about this. My linear theorem states that if two angles form a linear pair, then they are supplementary. Well, my given is two angles forming a linear pair. So we broke that down to angle 1 and angle 2 form a linear pair. And I'm going to prove the angles are supplementary. We're going to prove that angle 1 and angle 2 are supplementary. Now, in order to do this, I need a robust picture to help me prove this. So I'm going to draw a really good set of a really good linear pair. And I'm going to call this points A, C, B, and B and D, and angles 1 and 2. Now notice I have drawn a given. Angle 1 and 2 form a linear pair. I have drawn my given. Well, let's talk about things we know for sure, okay? My first thing I know for sure is what I'm given. I know that angle 1 and angle 2 form a linear pair, and I know that because they gave it to me in the problem. Now, what does it mean to be a linear pair? Well, my definition of a linear pair is a pair of angles whose sides are opposite rays. So something else I know is that CA and CB must be opposite rays because that's how we defined a linear pair of adjacent angles whose non-common sides are opposite rays. Well, we also know that angle ACB is a straight angle, and we know that by the definition of a straight angle. Well, straight angles also have 180 degrees, and I like that because 180 degrees has to do the word supplementary. So that's going to be my fourth step. So we know that ACB is 180 degrees by the definition of a straight angle. Well, I'm trying to get that 1 and 2 are supplementary. Now, we know that supplementary angles must add to be 180 degrees. Well, now I can look and see that angle 1 and angle 2 add together to be angle ACB by our segment addition postulate. So I'm able to say that the measure of angle 1 plus the measure of angle 2 equals the measure of angle ACB by the segment addition postulate. Well, now we've got a nice substitution here. I know that ACB is the same thing as 180, and I have ACB here, so I'm actually able now to go through and rewrite and say that the measure of angle 1 plus the measure of angle 2 must be 180 degrees by step 6, substitution, property of equality. Substitution, property of equality. And so what I've done, I've shown that that my two angles, angle 1 and angle 2, they add to 180 degrees. Well, guys, that's what it means to be supplementary. So I can finally say that angle 1 is supplementary to angle 2, and the reason I'm able to say that is by the definition of supplementary. And we're done. That should be a U, by the way, guys. And so we finished our proof. We have now proven that if you have a linear pair the angles are supplementary. And so guys, to end a proof, we have two ways to show that we're done with a proof. You can either do a little box and color it in, or you can write QED, which stands for something in Latin. I usually do the little cute box filled in because that's kind of a computer science method. That's a more modern method to show that you're done with a proof, but other teachers will also do QED, just to let you all know. So now I want to jump back and look at this, this vertical angles theorem. And the reason we didn't do the vertical angles theorem first will become apparent as we go through. So let's just quickly go through this proof together. If two angles are vertical angles, then they are congruent to each other. So I'm going to draw a diagram of a pair of vertical angles, okay? So here's my pair of vertical angles that I'm doing. I'm going to call them angle 1 and angle 2. So my given is angle 1 is vertical to angle 2. That's an angle sign, guys. And I'm trying to prove that they are congruent to each other. So I'm trying to prove that angle 1 is congruent to angle 2. And I can tell you for this proof, it's going to be helpful to have a helper angle, I'm going to call angle 3, in between the two. Now, the reason we proved the linear pair theorem first is that if you look here, angle 1 and angle 3 form a linear pair, and angle 3 and angle 2 form a linear pair. And that relationship is going to help me somehow relate angle 1 and 2 to each other. And without the linear pair theorem, it would be a lot harder to do so. So just be in mind, that's where we're going with this proof. So my first step is always to list the thing I'm given. And we're given that angle 1 is vertical to angle 2. Now, I now want to list how they're related to the thing that's going to help me prove. Well, again, my helper angle here is angle 3, and the way they're related is they're both linear pairs. So my second step is to say that they're both linear. So I say angle 1 is a linear pair with angle 3, and angle 2 is a linear pair with angle 3, and the reason I know that is that it's in the figure. It was given to me in the figure. Well, my third step now is going to be to interpret what it means to be a linear pair. Well, we just proved over here on the next page that if 1 and 2 form a linear pair, 1 and 2 are supplementary. So now we can say that if 1 and 3 are a linear pair, then angle 1 is supplementary to angle 3, and angle 2 is supplementary to angle 3. And the reason I'm able to say that is all the work I just did on that previous page, the linear pair theorem. And so guys, I couldn't have done this proof until I had proven the linear pair theorem, which is why we had to do that second page first, okay? Well, now I'm going to interpret what does it mean to be supplementary? Well, to be supplementary means that you're going to add to 180 degrees. So we write that down. Measure of angle 1 plus measure of angle 3 equals 180. Measure of angle 2 plus measure of angle 3 equals 180. And the reason I'm able to say that is that's my definition of supplementary. Now we've got a really cool thing. We've got two equations that both equal 180 degrees. And when that happens, I'm able to set them equal to each other, because if they both equal 180, then they equal each other. So I'm going to write that. Measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. And the reason we're able to do that, that's the transitive property, right? Two things equal the same thing, and they equal each other. Transitive property of equality, because we've got an equal sign. Well, now, do you see how we've got angle 3 on both sides? This means I can now actually go through and subtract angle 3 off both sides, leaving with the measure of angle 1 is equal to the measure of angle 2. That's by subtraction. And guys, remember, never, ever, ever shorten the word subtraction, because otherwise it will look like substitution. And if angle 1 is equal to angle 2, then we can say that they're congruent. Angle 1 is congruent to angle 2, and we're able to say that because that's what it means to be congruent. Definition of congruent. And guys, if we look up here, we were trying to prove that angle 1 is congruent to angle 2. We've now proven angle 1 is congruent to angle 2. We've met our goal, so we're done with the proof. That's all you got to do. Let's take a look at another example. We are going to take a look at the congruent supplements theorem. And the congruent supplements theorem says, and we're now on page 42, guys, that if two angles are both supplementary to a third angle, then those two angles are congruent. Or in other words, if 1 and 3 are both supplementary to angle 2, then angle 1 is congruent to angle 3. So let's draw this. I'm first going to draw angle 1 supplementary to angle 2. Okay, here's 1, here's 2. Now I'm going to add angle 3 into my diagram. Put some arrows on here to make this a little bit nicer. Well, angle 3 is also supplementary to 2, so that means they have to make a line together. So angle 3 is right here. So do you guys see, as I'm making this diagram, I'm actually creating some vertical angles here, right? But we are going to focus on our congruent supplements theorem. All right. So we always start off by listing our statements and reasons. Statement and reason. And we are going to list our givens first, always. Angle 1 is up to angle 2, angle 3 is up to angle 2, my reason is given. My second step is almost always going to be to interpret what that given means. Well, being supplementary to something means that you're going to add to 180. So that's what our second step is going to be. Measure of angle 1 plus measure of angle 2 equals 180. And measure of angle 3 plus the measure of angle 2 equals 180. And when we do that, we were able to say by the definition of supplementary, because that's what it means to be supplementary. Well, now, just like before, I've got both of these equal to the same number. This means I'm now able to set them equal to each other by the transitive property. So now I can say measure of angle 1 plus measure of angle 2 equals measure of angle 3 plus the measure of angle 2. And I'm able to say that, again, by the transitive property of equality. And now you've got this great situation where you've got measure of angle 2 on both sides. That allows you to subtract it off, leaving measure of angle 1 equal to the measure of angle 3. And so by subtraction, again, we never shorten the word subtraction or substitution. Subtraction, property of equality. And finally, I'm able to say that angle 1 is congruent to angle 3 by the definition of congruent. So guys, we were trying to prove 1 is congruent to 3. We proved 1 is congruent to 3. We are done with the proof. Okay, so now let's talk about how you're going to be graded on these, okay? When you write out a geometric proof, we're going to use this rubric to evaluate whether or not your theorem is correct. We're always looking for some structural elements. I'm looking for a sketch, your objects named and givens marked. I want all givens and to prove statements listed above the proof. A T-chart with your columns labeled statements and reasons. I want your statements numbered and in order. Statement and reason numbers correspond to each other, and we want to make sure that all of our naming conventions and symbols are correct. So these are just our basic required structural elements, okay? And we will rate you out of 3 points here. Then what's really important is the reasoning and the mechanics, okay? We want to see, are you giving clear evidence as you walk through, or are you jumping in between steps? Are there some gaps in what you are allowed to say and aren't allowed to say? Do you always have your statement flowing from the correct reason, or are you kind of mixed up? Okay, so we'll talk about this more in class together, guys. So this is your rubric, but we will go through this in class together next time. Let's take a look at a pretty basic proof. This is the right angle congruence proof. All right angles are congruent. Let's rewrite that first as a conditional statement. If two angles are right angles, then they are congruent. Well, drawing a sketch of this is pretty easy. I'm going to have two angles. They're going to be right angles and label them angle 1, right angle, angle 2. Pretty easy sketch. My given is that angle 1 is a right angle and angle 2 is a right angle. And my proof statement is that angle 1 is congruent to angle 2. So now we're ready to get going. We've got our statement column and our reason we're able to make that statement column, statement and reason, okay? We always start off with our givens. And our given in this case is angle 1 is a right angle and angle 2 is a right angle. Well, my second step is always to interpret my givens. What does it mean to be a right angle? Well, it means that the measure of angle 1 must be 90 degrees and the measure of angle 2 must also be 90 degrees, okay? And the reason we're able to say that is that it's the definition of a right angle. Well, now I've managed to set two things equal to the same thing. And whenever that happens, my mind is going transitive property. So that's what I'm going to do. I'm now able to say that because they both equal 90 degrees, the measure of angle 1 must equal the measure of angle 2 by the transitive property. Property of equality, because we're dealing with an equal sign. So I'm not quite to my final statement. My final statement is I want to show congruence. Well, I can convert this into congruence. Angle 1 is congruent to angle 2 by the definition of congruent. And we're done. That's the proof. Super simple 4-step proof. Gotta love it. All right, guys. The last proof is the supplementary right angles theorem. And actually, we're going to do in class together, okay? And we're going to do it with the rubric so that you guys get some good experience with doing this together. But I want you guys to go ahead and jump in and take a look at the practice. And I recognize that part of the practice has disappeared on my page, but y'all should be able to see it. So go ahead, try some of these out, see how it goes. Pay close attention. I give you some hints. So right here it says base your work on the congruent supplements theorem. That means it's going to mirror it pretty closely. It's the congruent complements theorem. The names are very similar, therefore they're going to prove very similarly. So go ahead and give those a shot and be sure to check your answers against the online key before you attempt the knowledge check. So thank you very much, guys.